The color-specific area tool is a great tool for basic presence-absence applications if you just need to know a feature or part is there or not. It is a tool that will count the number of pixels of a specified color in the inspection region and report back the pixel count. This tool is in the presence discrimination category of the tool list, as you can see here. In the function list, the generic tool name for this is the area tool. When you add the tool, the first step will be to register the image if you have not done so already. The registered image will be saved into the program settings and can be used as a reference image to set up the tool. When the desired image is on the screen, just click Register and the image will be saved into the program settings. Then click OK. Next, we'll set up the inspection region for the tool. This is the region of interest on the field of view where you want to count the presence of the pixels. The default shape is rectangle, but you can choose from rotated rectangle, circle, oval, ring, arc, or even up to a 12-pointed polygon. For this example, we're just going to use a rectangle, and we'll make it most of the screen here, as we're going to look for the presence-absence of this blue cap. After you have set your region, click OK, and you can now select the desired color. This tool will use what is called color-to-binary processing. You will select a desired color, and all the pixels in the region that are within your color range that you have selected will be set to 255 or white, and any pixels outside that range will be set to 0 or black. Hence, each pixel will be either set to 255 or 0. This is the binary processing. To select a color, click the Pick button and move the mouse on the image over the desired color and click. This will draw in the color of interest. The pixels that fall exactly within your selected range will be indicated in yellow. You can click more than once on the image to draw in more color. You can also expand the selected color range by clicking the Widen button, as you can see here. This will automatically widen or expand the selected color range based off the set sensitivity. The higher the sensitivity setting, the more color range it will extract when you either click on the image or click the Widen button. The region setting here sets the size of the eyedropper when you are picking a color on the screen. Again, the bigger the region, the more color it will extract on each click. The Omit button can be used to select colors that you want to omit from the color selection range. Back is kind of like an undo. If you click that, it will undo that previous step. You can reset the color or clear it out at any time and start over, or you can also copy a setup if you've already selected a color in a previous tool and want to use it in the same tool here. It is probably a good idea to test out your color selection on a variety of good parts and some known bad parts if you can, to confirm you have the correct color selected. You can change to the current image at any time by selecting it here in the upper left, as you can see here, or simply run some parts through the system by clicking Run. The Color Extract Image 1 here will show you, again, the pixels that you've selected will be shown in yellow. If you change it to Extract Image 2, this shows you that binary image. So all the pixels that are within your color range will be shown in white. All the colors that are outside your range will be shown in black. You can also show the raw image at any given time by selecting Raw 1. Here's an example of a red cap. If we change to the Extract Image 1, you can see there is no yellow indicated. And the Extract Image 2, there is no pixels at all. Again, so run some parts, confirm you have the correct color range. You can also pick color right off this current image if you need to select in more color. And it can be selected off the Extract Image 2 as well. So if I click Pick, I can draw in some more color if I want. As you can see here, that's it. When you've done picking the color, just simply click OK. Once you've extracted the desired color, you can now set the detection color of the tool under detection conditions. This is simply which pixels that you want to count. As a default, it is set for white. In other words, it'll count the pixels that are within your selected color range, as you can see here, and it will indicate the measured value here under the judgment conditions. If you change it to black, you can see the count change. This is the count of the black pixels, or in other words, the pixels that are not within your color range. Most applications you will select white. The last step in the tool setup is to set up the judgment conditions, or limits. This will dictate if the tool will pass or fail when executed. There is only one value to set a limit to in this tool, and it's the area, or pixel count. The measured value will display the currently measured pixel count for the image that is selected, and this could be the current image or the reference image depending on what you have selected. To set the limits, just simply click the field and set the desired limit. You can also run parts through as you are setting this limit. Click OK when the limits have been set and the tool setup is complete. You can now run parts and confirm the operation. You can see if the measured pixel count is within the upper and lower range, the tool is OK and passes. If the count falls outside the range, the tool will fail. As you can see here with the red cap, and here's the white cap. The blue passes, and the yellow one fails. So only the blue cap results in a pass operation, as you can see here. While the tool is running, you can always confirm correct operation by changing the image to the filtered image. So you can confirm that binary processed image. So if you're ever having trouble with the tool or it doesn't seem to be operating correctly, confirm the binary conversion in that filtered image and it should tell you the story.